Good afternoon, students. Today we will continue few more problems. Right? Take on the first problem. A person stand on the cliff, the edge of the cliff, on the edge of the cliff, 490 meter above the ground. 490 meter above the ground, and throws a stone horizontally with an initial speed with an initial speed 15 meter per second, neglecting air resistance, find the time taken by the stone to reach ground, and speed with which it hits the ground. Right? So this is the question. Right? So question first ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ನಾವು ಪ್ರಾಬ್ಲಮ್ ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ರೈಟ್? ಸೊ ಕ್ವೆಶ್ಚನ್ ಏನು ಹೇಳ್ತಾರೆ, a person stands on the edge of the cliff. Cliff nothing but mountain or hill. So edge ಅಲ್ಲಿ ನಿಂತಿದ್ದಾನೆ. For example, if I consider this one as mountain or hill, so ಯಾವುದೋ ಒಂದು edge ಅಲ್ಲಿ one person ಏನು ಮಾಡ್ತಾನೆ, ನಿಂತಿದ್ದಾನೆ. Right? So next, so height of the cliff, that means from the ground they given 490 meter. So ಎಷ್ಟು height ಅಲ್ಲಿ ಇದಾನೆ, 490 meter height ಅಲ್ಲಿ ಇದಾನೆ. Right? So next, throws a stone horizontally with an initial speed of 15 meter per second. So ಇಲ್ಲಿ ಮೇಲೆ ನಿಂತು ಇಲ್ಲಿಂದ ಏನು ಮಾಡ್ತಾ ಇದ್ದಾನೆ, ಒಂದು ಸ್ಟೋನ್ ನ ಥ್ರೋ ಮಾಡ್ತಾ ಇದ್ದಾನೆ. Right? So one stone is throwing with a velocity 15 meter per second, that is horizontal. Right? So throw ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, so it covers the distance like this. So ಈ ತರ ನಮಗೆ ಸ್ಟೋನ್ ಬಿಡುತ್ತೆ. ಇದೇ ತರ ಅಂತಾನೆ ಬಿಡೋದು, ಒಂದು ಬಾಲ್ ನ ಥ್ರೋ ಮಾಡಿದ್ರೆ ಸರ್ಟನ್ ಬಿಲ್ಡಿಂಗ್ ಹೈಟ್ ಇಂದ ಥ್ರೋ ಮಾಡಿದ್ರು it follows the parabolic path. Right? So neglecting the air resistance, find the time taken by the stone to reach the ground. So ಇಲ್ಲಿ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, time taken by the stone to reach the ground. Next, speed with which it hits the ground. So when the stone reaches the ground, so ಇಲ್ಲಿ ಏನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು, speed of the stone. Right? So they given only the speed, that is 15 meter per second. If we call this one as speed 15 meter per second, so ಯಾವ ಸ್ಪೀಡ್ ಇದು ನಮಗೆ, ಸೊ ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಮಗೆ ಇನಿಷಿಯಲ್ ಅಥವಾ ಫೈನಲ್ ಸ್ಪೀಡ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋದಿಲ್ಲ. ಸೊ ಇನಿಷಿಯಲ್ ಸ್ಪೀಡ್ ಅಂದ್ರೆ u ಅಂತ ನಾವು ತಗೊಂತೀವಿ, ಅಟ್ ಲೀಸ್ಟ್ v ಅಂತ ನಾವು ತಗೊಂತೀವಿ. ರೈಟ್? the stone is thrown horizontally. so projectile motion ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ಸ್ಪೀಡ್ ಇರುತ್ತೆ, ಒಂದು horizontal speed, another one is vertical speed. so ಈ ಸ್ಪೀಡ್ ಯಾವುದು ನಮಗೆ, horizontal or vertical? ಯಾವ ಸ್ಪೀಡ್ ಇದು? horizontal ಥ್ರೋ ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ it's horizontal speed, that means bx. Right? So we need to find the time taken to reach the ground and the total speed. So illi we find out ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, so here at this point we have both the horizontal speed along with that vertical speed. Right? So ಈ ಗ್ರಾಫ್ ನೆನಪಿದೆ ನಿಮಗೆ, projectile of the parabola. Right? So if an object is thrown with a velocity u, we have along ux as horizontal component, uy as vertical component. So each and every point ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ ux, uy. So at the highest point only we have only ux. So here uy is 0, right? So next somewhere here if I take so ux, uy. So ಇಲ್ಲಿ ಕೂಡ ಪಾಯಿಂಟ್ ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ux, uy. So same diagram ನೆನಪಿದೆನಾ? So ಇದರಲ್ಲಿ ಏನು ಹೇಳುತ್ತೆ? At the highest point vertical velocity ಏನಿದೆ ನಮಗೆ 0. So in this problem also he is at the highest point. That means here the vertical velocity uy that is equals to 0. So this 15. So vx ಕೊಂಡಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಕೂಡ vx equals to 0, vx is equals to 15 meter per second. So now we need to find the time. So height ಗೊತ್ತಿದೆ, velocity ಗೊತ್ತಿದೆ. So ಇವಾಗ time ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಯಾವ velocity ತಗೊಂತೀವಿ? Horizontal or vertical? So first difference ಗೊತ್ತಿರಬೇಕು. ಡ್ರಾಪ್ ಮಾಡೋದಕ್ಕೂ ಥ್ರೋ ಮಾಡೋದಕ್ಕೂ ಡಿಫರೆನ್ಸ್ ಏನಿದೆ? So one important relation ನಾವು ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಫೈಂಡ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. So there is a difference in dropping and throwing. ಎರಡಕ್ಕೂ ಡಿಫರೆನ್ಸ್ ಏನಿದೆ? ಡ್ರಾಪ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಅದರ ವೆಲಾಸಿಟಿ ಏನಿದೆ? Its initial velocity is 0. Throwing means it has some initial velocity. So we are going to find the time taken. So that means vertical displacement. So from the relation y is equals to voy plus, so it is downward motion, that is y of g t square, right? So displacement, so this displacement gives what? Vertical displacement, right? So namige ಬೇಕಾಗಿರೋದು ಯಾವುದು? Vertical displacement, because they given the height, right? So now y is 490, that is equals to, so vertical velocity is the vertical velocity 0, right? 0 plus 1 by 2 into g, take a 9.8 t square. So we can find the t, right? So 490 into 2 divided by 9.8, that is equals to t square, right? So 490 into 2, 980 divided by 9.8, that is equals to t square. So if we shift one decimal, we get 9800 divided by 98, that is equals to t square, right? So 98 ones are 98, hundreds are 9800. So if you remove the square root, then time taken is 2 seconds, right? So now we calculate model time. So next, the speed with which it hits the ground. So when it reaches the ground, it has both the velocity ux and uy. That means velocity along x-axis and velocity along y-axis. So ಇಲ್ಲಿ initial velocity 0 ಇದೆ. So ಬರ್ತಾ ಬರ್ತಾ ನಮಗೆ velocity ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ? Increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So for that we need to find the vx velocity, that is vy, that is equals to voy plus g, that is v is equals to u plus at. So voy is 0, so vy is equals to g is 9.8, sorry, this square is 10 seconds. ಏನು ಮಾಡ್ತಿದ್ದೀರಾ? ಹಂಗೆ ಬರ್ಕೊಂಡಿದ್ದೀರಾ 2 seconds. So root 100, that will get 10 seconds, right? So 9.8 into 10, so we get 98 meter per second. So this is the vertical velocity, right? So namge horizontal velocity already they mentioned. So we find the velocity, that is vertical velocity 98. So with which the speed hits the ground means v is equals to under square root of vx square plus vy square, right? So square root of 15 square plus 98 square, right? So v is equals to 225 plus 98 square, 9601, 604 plus 225, so under square root 9801 29. So we get the velocity how much? Under square root 9829. So approximately 99.12 or 22 meter per second. Right? So these two problem. So ಇದರಲ್ಲಿ ನಾವು ಏನು ಕನ್ಕ್ಲೂಡ್ ಮಾಡಬಹುದು? ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಡ್ರಾಪ್ ಮಾಡೋದ್ರುನು ಥ್ರೋ ಮಾಡೋದ್ರುನು ತಗೊಳ್ಳೋ ಟೈಮ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಏನಿರುತ್ತೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಕ್ಯಾಪ್ ಇದೆ, ಈ ಕ್ಯಾಪ್ ನ ನಾವು ಇಲ್ಲಿ ಈ ತರ ಡ್ರಾಪ್ ಮಾಡಿದ್ರುನು ಇಟ್ ಕವರ್ಸ್ ಸಮ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ಥ್ರೋ ಮಾಡಿದ್ರು ಕೂಡ ಇಟ್ ಕವರ್ಸ್ ಸಮ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಸೊ ಬೋತ್ ಟೈಮ್ ವಿಲ್ ರಿಮೈನ್ಸ್ ದ ಸೇಮ್. ಡ್ರಾಪ್ ಮಾಡೋದಕ್ಕೆ ಮತ್ತು ಥ್ರೋ ಮಾಡೋದಕ್ಕೆ ಎರಡು ತಗೊಳ್ಳೋ ಟೈಮ್ ಏನಿರುತ್ತೆ ನಮ್ಗೆ ಆಲ್ವೇಸ್ it remains the same. So we can write the formula T is equals to under square root of 2h divided by g. Right? The reason because vertical velocity in vertical displacement always its initial velocity is 0. From the certain height alli now drop ಮಾಡ್ತಾ ಇದೀವಿ ಅಥವಾ throw ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ always the vertical velocity ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. Right? So on that basis the time which takes to reach the ground from the certain height, it will be defined T is equals to under square root 2h divided by g. So constant, g constant, T is directly relates with h. So height change ಆಗ್ತಾ ಹೋದಂಗೆ time taken ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, change ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Take the next problem. So problem is based on relative velocity, right? So rain is falling vertically with a speed of 35 meter per second. A woman rides a bicycle with a speed of 40 vertically means falling from the sky to the ground. So either direction togobekku, opposite togona barudha barada, right? So with a speed of 35 meter per second, so we call this one as speed of rain, right? So next, a woman rides a bicycle with a speed of 12 meter per second in east to west direction. So from east to west means this direction, right? So one woman, she is riding a bicycle with a speed, so VB, that means speed of the bicycle. So how much they given? 12 meter per second, right? So we need to find what is the direction in which she holds the umbrella, right? So jotege ಒಂದು umbrella carry ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So umbrella ನ ಯಾವ direction ಅಲ್ಲಿ hold ಮಾಡ್ತಾಳೆ ಅನ್ನೋದನ್ನ ನಾವು ಫೈಂಡ್ ಮಾಡಬೇಕಾಗುತ್ತೆ, right? So if we return these two, so ಇಲ್ಲಿ ನಮಗೆ ಕೊಟ್ಟಿರೋದು velocity of rain with respect to the ground, right? So velocity of the rain is 3 meter per second means this is the speed with respect to the ground, and she rides a bicycle 12 meter per second means she riding the bicycle with respect to the ground. So ಈಗ ಅವಳು ಒಂದು umbrella ನ hold ಮಾಡ್ತಾ ಇದ್ದಾರೆ with respect to what? The rain. So rain based on the direction ಅಲ್ಲಿ, that is she has to hold the umbrella. That means the relative velocity of the bicycle with respect to rain or rain with respect to the bicycle. So umbrella hold ಮಾಡ್ತಿದ್ದಾಳೆ ಅಂದ್ರೆ ಯಾವುದಕ್ಕೆ umbrella hold ಮಾಡ್ತಾ ಇದ್ದಾಳೆ? Opposite to that of the Right. So ಇದರಿಂದ ಏನದು so that means to cover. So line the cover ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೋಸ್ಕರ she holds the umbrella. So ಅದು ಯಾವ direction ಅಲ್ಲಿ ಇದೆ? First we need to find the relative velocity of line with respect to bicycle. That means v or b. That means relative velocity of the line with respect to bicycle. So we have velocity of the line minus velocity of the bicycle, right? So ಇದು ನಮಗೆ one dimensional motion ಅಲ್ಲಿ derive ಮಾಡ್ಕೊಂಡಿರೋ relation, right? So now if I write this one in the vector form, right? So this is only the magnitude. If I write the velocity of the line, right? Magnitude 35. So in which direction it is? Vertical direction. So direction j cap. 35 j cap. So positive axis ಅಲ್ಲಿ ಇದೆನಾ negative axis ಅಲ್ಲಿ ಇದೆನಾ ಇದು? ಯಾವ axis ಅಲ್ಲಿ ಬರುತ್ತೆ? Negative axis. So minus. If it is in the upward direction means positive axis, right? So same wise velocity of the bicycle, right? So that is equals to, so direction from east to west. So this is also in which direction? That means which axis? Your direction allo hogta ide negative x axis. That's why minus 12 I cap, right? So now the relative velocity in terms of vectors, right? So vector chapter ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ನಾವು vectors through ಇದನ್ನ derive ಮಾಡ್ತಾರೆ, right? So v or b, in place of v or we need to write minus 35 j cap minus of vb minus 12 I cap, right? So minus into minus plus. So first we will write I cap, that is along x axis, minus 35 j cap. So this gives what? The relative velocity of the line with respect to the bicycle. So ಇಲ್ಲಿ observe this, the magnitude of the velocity of the bicycle is positive. That means the relative velocity, she is moving with respect to line in this direction, right? So velocity of the bicycle is equals to 12 I cap, right? So now I will draw parallel here, B or B, that is equals to, so minus 35 j cap. So again by the method of parallelogram law of vector addition. So this is one vector, another vector. So if we complete this one, we get one parallelogram. So resultant will give in this direction, right? So you can take angle either here theta, or you can take angle theta here. So in this direction she is holding the umbrella. So directionally she holds the umbrella, right? So for that we need to find the angle theta. So this angle theta on the tone, right? If we complete this one, so in cases alone now define ಮಾಡಬಹುದು. So first if I take an angle theta with the vertical, then tan theta is equals to opposite side by adjacent side. So opposite is how much? 12, adjacent side by is 35, right? So 12 by 35, hmm? 0.342, right? So we need angle theta. Angle theta is equals to tan inverse of 0.342. So open the tan, natural tan, and find the value 0.342. So we get angle theta here approximately some 18 degrees. So this angle theta is some approximately 18 degrees. 18, not 18, it's 18.9. So we get approximately 90 degrees. So that means she holding the umbrella south of east. So reference now vertical. Vertical means which direction it is? South. So is in this direction she is holding the umbrella. So that's why she holds the umbrella in the direction of south of east. So south in the east kadage she holds the umbrella, right? So if we taken theta here with the horizontal, right? So if we taken angle theta is here, tan theta opposite side by adjacent side. That means 35 divided by 12, right? So you can calculate any one method. So ಇಲ್ಲಿ angle theta ತಗೊಂಡ್ರೆ east of south. So east in the south ಕಡೆಗೆ. So it is 19 degree means 90 minus 19, right? So almost we get some 71 degrees, right? So 71 degrees towards east of south and 18 degrees towards south of east. So ಯಾವುದನ್ನಾದರೂ ಒಂದನ್ನ direction ಆಗಿ ತಗೋಬಹುದು, right? So this is the problem which we solved based on the vectors. So relative velocity first find out ಮಾಡ್ಕೊಂತೀವಿ, later we can simplify, right? Otherwise same you can draw like this. So this gives what? Vector bb 12 I cap, right? So the resultant will be in this direction. If we complete the triangle, so this line gives what? The resultant, and this is the angle theta, right? So any one method, right? Either triangle of addition or parallelogram law of addition. So this is from triangle law, right? So this is from parallelogram law, right? ನಿಮಗೆ ಡೈರೆಕ್ಷನ್ಸ್ ಕನ್ಫ್ಯೂಷನ್ ಅಂತಂದ್ರೆ angle theta 17 degree with vertical ಅಂತನಾದ್ರೂ ಬರೀಬಹುದು, right? Or 71 degree with horizontal. So next, third type, a stone is tied to the end of a string, that means thread, which is 80 centimeter long, is drilled in a horizontal circle, with a constant speed if the stone makes 14 revolutions in 25 seconds. What is the magnitude and direction of resultant acceleration, right? So question one stone is tied to the end of the string. So string is nothing but thread. So ಯಾವುದೋ ಒಂದು ದಾರಕ್ಕೆ ಒಂದು stone ನ tie ಮಾಡಿದ್ದಾರೆ. So next, the length of the thread is 80 centimeter, right? So that is drilled means circled or revoluted, that one, right? So along the horizontal circle with a constant speed. So speed is constant. If the stone makes 14 revolutions in 25 seconds, right? So we need to find the magnitude and the direction of the acceleration, right? So consider this one as the thread length. So here is the center O, right? So here somewhere one stone is there. The length of the thread is 80 centimeter. So ಅದನ್ನ rotate ಮಾಡ್ತಾ ಇದ್ದಾರೆ. So rotate ಮಾಡ್ತಿದ್ದಾರೆ ಅಂದ್ರೆ along horizontal. So horizontal ಅಲ್ಲಿ rotate ಮಾಡಿದ್ರೆ ನಮಗೆ ಯಾವಾಗಲೂ in two dimension it should be in the ellipse shape, right? So last class ಅಲ್ಲಿ ಹೇಳಿದೆ horizontal vertical motion and horizontal motion, right? So vertical ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ we are taken circle. So horizontal is in the ellipse shape, right? So, but that is also circle, right? So we need to find the magnitude and direction of the acceleration. So direction ಗೊತ್ತಿದೆ. In a circular motion, the centripetal acceleration is always acting towards the center. So we need to find the acceleration. So we know the formula acceleration AC is equals to v square divided by r. So this is linear velocity with respect to the radius. So radius r is equals to 80 centimeter. We need to convert that one in terms of meter. 80 into 10 to the power of minus 2 meter. So we get 0.8 meter, right? So one more formula, AC is equals to omega square r. So omega is the angular speed, right? So we know the forms of omega, that is equals to 2 pi nu. That means the frequency, or we can write this one as 2 pi by t, time period. So they mentioned 14 revolutions in 25 seconds. So definition of the time period is the time taken by the stone to rotate. That means revolute one rotation, right? So one complete rotation ತಗೊಳ್ಳೋದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ one time period. So frequency is the number of revolutions in 1 second. That one we call as the frequency, right? So in given questions they mention 14 revolutions in 25 seconds, right? So but the definition is time period is for one revolution. So one revolution get time period ಅಂತ ಕರೀತೀವಿ, right? So here for one revolution it becomes 25 divided by 14. So 14 revolutions get 25 seconds to one revolution get 25 divided by 14. So this gives what the time period t, right? So either we can substitute AC is equals to 2 pi by t whole square into r, right? Otherwise we can convert this one in terms of frequency, that is 1 divided by t, it becomes 14 divided by 25, that is revolutions per second. So ಯಾವುದಾದರೂ formula use ಮಾಡಬಹುದು, right? So here 2 pi f r nu whole square into r, right? So AC is equals to 4 pi square nu square r, right? So 4 into this 22 divided by 7 whole square into, so the frequency 14 divided by 25 whole square into 0.8. So if we simplify, we get the magnitude of the acceleration, centripetal acceleration. Otherwise directly 14 divided by 25 is what the value, 14 by 25, 0.56. So substitute directly here. So AC is equals to 4 into 3.14 whole square into 0.56 whole square into 0.8. So if you multiply all this, we get the magnitude. So answer is for the AC. .89 meter per second. 9.49. 9.89 meter per second square, right? So this gives what the magnitude of the acceleration, and the direction is always towards the center of the circle. The next method, a cyclist is riding with a speed of 8 meter per second, 8 meter per second, as he approaches a circular turn on the road of radius 80 meter. He applies a brake and reduces his speed at the constant rate of 0.5 meter per second every second. What is the magnitude? And direction of net acceleration of the cyclist on the circular turn. So question is, cyclist is riding with a speed of 8 meter per second, and as he approaches a circular turn on the road of radius 80 meter. So radius को इधर 80 meter. Now he applies a brake and reduces his speed at a constant rate of 0.5 meter per second, that is every second. So here what is the magnitude and direction of the net acceleration? So there is a difference in centripetal acceleration and to that of the net acceleration, right? We need to find the magnitude and direction of the net acceleration, right? So first time a cyclist is moving in a straight road. So that means the cyclist is riding with a speed of 8 meter per second, means he is moving with a speed 8 meter per second. So that is on a straight road, right? As he approaches a circular turn, so after he approaches one circular turn, he applies the brakes at the circular curve, right? So this curve is a radius of 80 meter, right? So a curve get radius mention ಮಾಡಿದ್ದಾರೆ, that is 80 meter, right? So he is applying the brake at the point A and he reduces his speed at a constant rate of 5 meter per second. That means he is moving with a constant speed, right? So speed is 0.5 meter per second. So it is speed. That means only the magnitude of the velocity. So from the centripetal acceleration at each and every point, direction ಏನಾಗ್ತಿದೆ ನಮಗೆ circular path ಅಲ್ಲಿ change ಆಗ್ತಿದೆ. So as the direction changes means the velocity is changing, but it has the constant speed. So speed ಗೆ velocity ಗೆ difference ಏನು ಅಂದ್ರೆ it is moving in a straight line means that becomes the speed. The magnitude constant ಇರಬಹುದು. Velocity ನ ಯಾವಾಗ ಕರೀತೀವಿ ಅಂದ್ರೆ the direction change ಆದ್ರೂ ಕೂಡ so this is what velocity, right? So velocity is the vector, it has magnitude and also the direction. So we have two types of velocity. One is variable velocity, another one is uniform velocity. So in uniform velocity, the object or particle moves with a constant magnitude in a same direction. That means the object which is moving in a straight line, right? So direction change ಆಗ್ತಾ ಇಲ್ಲ ಮತ್ತೆ magnitude ಕೂಡ change ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರೀತೀವಿ uniform velocity, right? So uniform velocity magnitude ಏನಿರುತ್ತೆ constant ಇರುತ್ತೆ. For example, the object is moving some 5 meter per second each time it covers 5 meter per second, right? So direction ಏನಾಗಲ್ಲ change ಆಗಲ್ಲ. So straight line ಅಲ್ಲಿ constant magnitude in the same direction. Change ಆಗ್ತಿಲ್ಲ, magnitude change ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ it is moving with a uniform velocity. So from this we have the acceleration v minus u divided by t. That is v is equals to u plus at. We can write that one as a is equals to v minus u by t. So where v is the final velocity, u is the initial velocity. So initial point allu namage 5 meter per second ide, final point allu kuda namage 5 meter per second ide. So there is no change in velocity. So there is no change in velocity means acceleration is equals to 0 when there is in uniform motion. So uniform velocity alli idaga acceleration 0 irutte, right? So namge ile ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ it has a constant magnitude. So magnitude ಏನಿದೆ constant ಇದೆ but direction ಏನಾಗ್ತಿದೆ change ಆಗ್ತಿದೆ. So ಅದು ಯಾವಾಗ variable velocity. So variable velocity na yav ತರ define ಮಾಡ್ಕೊಳ್ತೀವಿ either the magnitude may vary. So first to 5 meter per second ಇದೆ, next to 4 meter per second, next to some 2 meter per second. So magnitude ಏನಾಗಬಹುದು change ಆಗಬಹುದು, direction ಏನಿರುತ್ತೆ same ಇರುತ್ತೆ. Or the second case is magnitude remains same. So all the cases ಅಲ್ಲಿ ಕೂಡ magnitude ಏನಿರುತ್ತೆ same ಇರುತ್ತೆ, direction ಏನಾಗಬಹುದು change ಆಗಬಹುದು, right? So ಎರಡು ಸೇಮ್ ಇತ್ತು ಅಂದ್ರೆ ಯೂನಿಫಾರ್ಮ್ ವೆಲಾಸಿಟಿ, ಎರಡರಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ವೇರಿ ಆಗ್ತಿತ್ತು ಅಂದ್ರೆ ಅದನ್ನ variable velocity. So if we have variable velocity then we have acceleration, right? So idu artha agidre illi artha agutte. So illi moving with a constant speed or constant velocity moving in a straight line means it is in a uniform motion, right? So when he approaches to the circular path, so he applies the brake, so that means magnitude remains same. So circular path alli at each and every point kuda direction enagtide namage change ಆಗ್ತಿದೆ. That means we are getting the acceleration, right? So if you find decreasing, so acceleration ಏನಾಗ್ತಿದೆ ನಮಗೆ decrease ಆಗ್ತಿದೆ. So velocity is also a vector, acceleration also vector. So velocity upward direction ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ acceleration ಏನಿರುತ್ತೆ ನಮಗೆ downward direction, because acceleration is decreasing. That means negative acceleration. So negative acceleration is opposite to that of the velocity. So this gives what a at, tangential acceleration, we call that one as at. So here always we have the centripetal acceleration. So first we need to find the centripetal acceleration and tangential acceleration. So these two are the vectors. So somewhere here by the method of parallelogram law of addition we getting the net acceleration. Right? Magnitude of net acceleration, right? So magnitude of the net acceleration, that is equals to square root of ac square plus at square, right? So now AC, we have the formula, right? So AC is equals to V square divided by R. So V either nಮಗೆ 0.5 and R. This is 8. 8 square divided by 0.8. Right? So we getting AC is equals to 64 divided by 0.8. So that means 640 divided by 8. Right? So how much we are getting? 80. So AC bantu next 80. That means tangential acceleration, that is opposite to that of the velocity. So direction change of the magnitude remains same, means the acceleration AC is equals to 80, that is equals to 0.5 meter per second square. So substitute here. So what is square root of 80 square plus 0.5 whole square. So simplify what is square root of 80 square plus 0. That is under square root. So we get some value. So that value is the magnitude of the net acceleration. So idu net acceleration, right? So if we take an angle theta here, that is the direction. So tan theta is equals to opposite, that is 80 divided by AC, right? So theta is equals to tan inverse of 80 0.5 divided by A. Here the radiation is 80, right? Previous problem, let's go there. 8. 8 square plus 0.5 square. So it is already in meters, right? 64 plus 0.025, 0.25, that is under square root. ಕ್ಯಾಲ್ಸಿ ಇಟ್ಕೊಂಡು ಕೂಡ ಇಷ್ಟೊಂದು ಟೈಮ್ ತಗೊಂಡ್ರೆ ನಾಳೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ? 32.25 meter per second square. So here 0.5 divided by 8, that is 1 by 16. 1 divided by 16. So 0.5 now 1 by 2 on the variable, right? Opposite 80 by 0.06. So we get approximately some 3 degree. So direction is 3 degree, right? So by this we completed the topic, this chapter, motion in a plane. So from tomorrow we'll start with new chapter, that is laws of motion, right?